Okay, Foundations of Pre-Cal 10. This is the last video in our grade 10 curriculum, so we're going to finish here with interest and deductions. So let's start with interest. So interest is amazing. It can also be brutal, but those are conversations to have in class. And we'll start with simple interest. So simple interest is given by this equation, I equals PRT. Okay, so I is equal to, yes, your interest, the amount of interest you gain, or owe. P is what we call your principal, okay? And your principal is the amount of money borrowed or the amount of money saved or invested. R is your interest rate, and that is given as a decimal, which is then a percentage. And then T is time, and time is represented in years. So here's our example. How much interest is paid over a 3-year period on a $5,000 loan or a $5,000 investment at an APR, annual percentage rate of 3%. So if we have I equals PRT, well, we know that my P is equal to 5,000. My R is 3%, which is 0.03. And my 3 years is my time, 3. So this now just becomes multiplication. 5,000 times 3 times 0.03, I make $450 in interest. Now, that's pretty nice. That's a free $450. You just didn't touch your money for 3 years. So interest is free money, so take advantage of it. Now, if you owe, interest can suck. And that's why I say interest can be, simple interest and compound interest can have perks and cons. So what principal, now here's a work backwards scenario, okay? What principal at $4.75 will, or 4.75% will earn $27.15 in interest? Now here's something to look out for. 9 months. Remember, time is in years. Well, what's 9 months with respect to years? Well, 9 months out of a possible 12 months, that would be years. So that would be 3/4 of a year. Okay, so that's the first thing to look out for. Now in this case, I equals PRT. We know that I was 27.15. We don't know P. We know R was 0.0475. And we know that T is actually 3/4. Or, for those of you that like decimals, 0.75. If you haven't learned how to use your fraction button on your calculator yet, now would be a good time to ask whoever you're working with. So we got to calculate this out. So I'm going to go 0.0475 times 3/4, and it gives me a long decimal expansion. So I'm going to round, probably around 4 decimal points, but remember we're talking money. So I have 0.03563, just for the sake of as accurate as we can get. And I'm going to divide both sides by that number. So 27.15 divided by that, and you get 762.1, and I'm rounding to 1 because we're talking money, so we round there. So that would be my principal, right? I'm dividing by that number on both sides. So you're doing just a bit of algebra to solve for the missing information. By this point, I'm sure you're comfortable. This would be the hardest part, making sure our time is actually in years. All right? So here's the big deal. Compound interest. This is what changes lives for both the better or the worse. This is why people with money make a lot more money and why people who borrow money have a hard time getting out of that cycle. Because compound interest earns interest on your interest that you've already earned. You are earning interest on your free money. This is amazing. But you can see we have a few extra letters. So here, A is my amount. It's no longer my interest, okay? P is still my principal, but R is still my interest rate. T is still time in years, but N's our new one. N is what we call our compounding periods, okay? So you can compound annually, which is once a year, semi-annually, which is twice a year, quarterly, which guess what, is 4 times a year, daily, how many times a year? 365. Monthly, right? A whole bunch of different compounding periods. So be aware of that. So here we go. How much interest is earned if you deposit $6,500? Okay, so P is $6,500 in an account paying 6%. Oh, okay, so R is 0.06. Compounded monthly, okay, so 12 months in a year, so N is 12. and t 5 years. So there, I have the information I need. So A equals P times 1 plus R over N to the power of N times T. So really important that you key these things in at the right time. So 6,500, and then 1 plus 0.06 over 12 to the power of 12 times 5. So you got to do inside the brackets first. So 0.06 divided by 12 plus 1, you now have A equals 6,500 times 1.005 to the power of 12 times 5, which is 60. So now you have to do the power, this part next. So to the power, your calculator probably has a button that looks like that, or maybe like that. That's your power button. So 1.005 to the power of 60. And then it's 1.3488, da, 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 da. I'm just going to hold it there. I'm going to hit times 6,500, and I get my new amount. I get A equals 8767.53. Now, you're not done, because what did this question ask? This question asked, what interest is earned? Well, obviously, the amount is now your new total amount. So in order to get interest, you take your amount and you subtract your original principal. So we take our new amount, we subtract our $6,500, and you'll see that your interest in this case, I is equal to 2267.53. So you earn a substantially more interest in compound interest than you do in simple interest, because you're earning interest on your interest. It's amazing stuff. So let's work backwards. What initial investment is required to become a millionaire in 25 years? So what information do we have? We know that A has to be a million. P is what we're trying to find out. R is 0.12. That's a very high interest rate. You're lucky if you find someone who can earn you that. N is quarterly, so 4, and time is 25. So if you are 20 years old, you'll have this amount by 45. So if you can find this principal, invest it. If you can keep, but invest it in a moderate to low risk, so you're not going to lose it all. But let's see how this works. 1 million equals principal times 1 plus R 0.12 divided by N 4 to the power of 4 times 25. So remember, do the inside first. So 0.12 divided by 4 plus 1, you get 1 million equals the principal times 1.03 to the power of 100. So now we do that part, which gives you 1 million equals principal times a very long number. So 19.218 da 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 da. And we're just going to divide both sides by that amount. So 1 million divided by that is P equals $52,032.84. So if for some reason you manage to come across $52,000 that you are willing to invest or able to invest in 25 years at a 12% interest rate, which is high, but you'll have $1 million. And if you think 25 years is a long time, it's not. 25 years creeps up pretty quick. So keep that in mind. If you ever have a windfall of cash, doesn't have to be 52 grand, but if you get an inheritance or you win a lottery or some positive thing happens in your life where you end up with a good chunk of change, talk to an investor about how you can invest that money, because it compounds quickly. So here's one where we're going to have 3 different scenarios. Okay, now the equation more or less holds up the same, except what changes is our n value. Because in the first one, n is compounded yearly, second one, n is compounded monthly, and the third one, n is compounded daily. So our equation will line up the same, okay? A equals $8,000 investment 1 plus, now in this case, R is going to be 6% in all cases, but here I'm dividing by 1, and I have 1 times 10 years, so just 10. This one's going to change because now it's going to be compounded monthly, so 1 plus 0.06 over 12, and now I have 12 times 10, so more compounding periods. And here I have A equals 8,000 times 1 plus 0.06, but over 365, and I have 365 times 10, so way more compounding periods. So you can see the more compounding periods you have, the better off you'll be. And you'll see it'll make a difference. Won't necessarily make the hugest difference, but it'll make a difference. So crunch these through your calculator. 0.06 plus 1 to the power of 10, all times 8,000. And you get, in this case, 14,326.78. So that's pretty nice. Your money almost doubles in 10 years. So if we're compounding now, though, every month, we divide that 0.6 by 12, add 1, put it to the power now of 120, and multiply it by 8,000. So in this case, we get 14,555.17. So you can see not drastically more, but $200-ish more, just because more compounding periods. So now the last one, 0.06 divided by 365 to the power now of 3,650, way more compounding periods. So 0.06 divided by 365 to the power of 3650, and then multiply that by 8,000. You get 14,576.23. So again, not tremendously more than that one, but the more compounding periods you have, the more you end up making. So if the amount of your principal increases, the more compounding periods you have the potential to earn you the most amount of money. So keep that in mind. So that's all well and good. That's gross, but what about deductions? Okay, that's when we go from your gross, I don't know why they say gross, but your gross pay to your net pay. Your net pay is what you actually get to take home. So a lot of times people complain to me, how come we didn't learn how to do our taxes in high school? Well, one, your taxes are really easy unless they're not. And if they're not easy, you hire an accountant to do it for you. If they are easy, you can download software to do it, or you can take it to H&R Block and pay someone $20 and they'll do your taxes for you. It's more about where is your tax money going and why are they taking it off that's important. And that's what we're going to talk about here briefly. Now, we're only going to talk about 3 main deductions. You can have a myriad of deductions off your pay stubs, but here we're going to talk about CPP, EI, and income tax. So CPP is a Canadian pension plan, okay? That is what you get when you get old enough to get a Canadian pension. Everyone pays into it because ideally when you get to that age, you then reap those benefits too. I say ideally because right now there's a lot more people who are receiving CPP than those paying into CPP. So those paying into it might not have as much left by the time they get to that age, but that's a bridge we will cross. EI is what you call employment insurance. So it's something where if you were to get laid off or lose your job through a fault that is not your own, you can apply for EI, which pays you a percentage of your salary until you're able to find a new job or into a maximum amount of payouts. So you kind of pay into that as almost an emergency fund from the government. And then income tax is the tax they deduct off your income, and it is given by a determined amount by the government, and it fluctuates, and it can be incredibly hard to average calculate, but I found a little average table that I've created just as an example. So here we go. In the notes, you'll see where I got this value from. I have a table of provincial and federal income tax average, so we'll use that. So Gwen makes $62,000 a year. Her semi-monthly gross pay is $2,583.33, and it's her first paycheck of the year. How much money will get deducted from CPP, EI, and income tax? So you could do this annually, but let's just do it from her gross paycheck. So she loses 4.95%, so 0.0495. She loses 1.66%, so 0.0166. And she loses 18.4%, so 0.1840. So you can add all those up to a total percentage amount that's going to come off of her paycheck. So add those up, and you end up with 25.1% of her paycheck, or 0.01% of her paycheck she's going to be losing. So we take her paycheck, and we multiply it by 0.2501. So off her paycheck, she loses $646.09. So that money gets deducted and goes to wherever it goes, CPP, EI, and income tax. And then you take her gross wage, her $25.83.33, and you subtract that amount, and you get her net pay or her take-home pay, which is $1937.24. So yes, that is what your paycheck says, but that is what you actually get. I mean, it says that on your paycheck too, but that'll be after deductions. Okay, so have a look through the notes. There's more examples on deductions. Deductions are a part of life. Where your tax money goes and what it uses, like what your income tax is used for, comes down to societal and political decisions, and you have impact on that based on who and what you vote for. So be aware that you do have a voice in what happens with your money, but often you don't, and it's just a part of life. There is a old quote that said there are 3 guarantees in life: you're born, you die, and you pay taxes. So there you go. Thanks so much, grade 10. See you in grade 11.